Hello class. Today we're going to start our newest unit and we're going to be working with rational expressions and eventually rational functions, and we're going to be graphing them. But before we graph them, we're going to do some arithmetic with them. Multiplying, dividing, adding, subtracting, that sort of thing. Today we're going to just do multiplying and dividing. So let's take a look at where we're going with that. So a rational expression, we should know what that is before we start doing things with it, right? So a rational expression is defined as f of x is equal to p of x over q of x. What does that mean? Well, p of x and q of x are polynomials, and we worked with polynomials last unit. So these are some things like, x squared plus 2x minus 3 over x plus 1, something like that. So there's a few steps that we use when we are going to be multiplying things that look like that. The first thing is we're going to factor everything. We're going to factor the numerators. We're going to factor the denominators. So factor all the numerators and denominators completely. Once that's done, we're going to look at the top and the bottom, the numerators and the denominators, so that if there's anything in common, we can cancel out those common factors that occur in both a numerator and a denominator, so top and bottom. And then what's left over, we can multiply those together. Multiply the remaining factors in the numerator and we'll do numerator times the numerator for the resulting numerator, and we're going to multiply the denominator by the denominator for the resulting denominator. Let's demonstrate that, okay? So we've got 2x squared minus 3x, and that's being divided by 2x squared minus x minus 3. And we're going to multiply, that's the multiplication symbol, times x squared minus 1 in the numerator, x squared plus 2x in that denominator. So I'm going to start by factoring this first denominator, 2x squared minus 3x. It has a common factor of x. If I factor that x out, it's being multiplied by 2x minus 3. In the denominator then, that 2x squared minus 3x minus 3 is going to be factored into two binomials. 2x squared factors into 2x and x. And that 3 is going to be 3 and 1, but we want that middle term to add up to negative 1. So this is going to be the 3, and this is the 1. We have a minus 3, minus, and a plus 1, so that this negative 3x, and that's going to be 2x, that adds up to our negative 1. And we're going to multiply that by x squared minus 1 is the difference of squares, so we can factor that into conjugates of x plus 1 and x minus 1. And then that x squared plus 2x has a common factor of x, and that's being multiplied times x plus 2. All right, so now we can factor out anything that's in common. So I have an x here and an x here, and I'm going to just cancel that out. I've got an x plus 1 in the bottom here and an x plus 1 in the top here. I've got a 2x minus 3 in the top and the bottom, and I have an x minus 1 in the top, not in the bottom. X plus 2 in the bottom, but not in the top. So this is what's going to be remaining. And that leaves me with an answer of x minus 1, minus, not plus, minus 1 over x plus 2. And that is my solution. So here's another one. You're multiplying. You're going to follow the same steps. Factor the numerators and the denominators completely. cancel out anything that is in common in both the numerator and the denominator. And then when you simplify, whatever's left over in the numerator gets multiplied to the numerator. Whatever's left over in the denominator gets multiplied over into the denominator. What I'd like you to do is just pause the video for a little bit and try it on your own, and then turn the video on to see how you did. So just check this step now and see if you factored everything correctly. So this is how it's going to look when you factor all of that. Check yours and then go ahead and start canceling things out. Wow, when you cancel stuff out, there's a lot of stuff that matches and you have only 2 left. So 2 is your answer. Very good. Now that you've had a practice doing multiplication, you'll be great at doing division. So dividing is really not that much different. You're going to end up rewriting that division problem as a multiplication problem, and we just did that. So it's going to be a division problem becomes a multiplication problem. You multiply the first term by the reciprocal of the second term. You guys probably have heard, where'd my pen go? Keep, change, and flip. All that means is when you're multiplying fractions, you're going to keep the first term, change the division to multiplication, and then flip over the last term. Once you've rewritten it as a multiplication problem, you're going to follow the same steps, 1 through 3, from when I gave you the instructions for multiplying. That looks easy enough. Let's give it a shot. So here we have a division problem. Before I do any factoring or anything, I'm going to do that first step and rewrite this as a multiplication problem. So the keep that we're going to do, oops, where'd my pen go? We're going to keep this first one. I think I'm going to change colors. So we're going to keep that 3x squared minus 6x over 6x squared minus 24. And we're going to change the division to multiplication. And then we're going to flip that second term. So x plus 2 goes on the top, and the 3x squared plus x goes on the bottom. Now I'm going to factor. So 3x squared minus 6x has 3x in common. And we're going to multiply that by x minus 2. In the bottom, 6x squared minus 24. Well, we have a 6 in common. And that leaves us with x squared minus 4. But that x squared minus 4 is a difference of squares. So we're going to factor that too. So we're going to have 6 times x plus 2 times x minus 2. And then we're going to multiply that x plus 2, let's just give ourselves a line, is primes. I can't factor that. But the bottom, 3x squared plus x, has a common factor of x. And I'm going to factor that. And so we'll have, 3x plus 1. All right, let's go ahead and do some canceling here. 3 and 6 have a common factor of 3. 3 goes into 6 twice, though, so we still have a 2 in the denominator. I see an x minus 2 in common. There is an x in common here and here. And there is an x plus 2 in common here and here. And in the numerator, everything got canceled off, but it's not nothing. Remember, we're factoring these to 1. So if everything is canceled off, there's still a 1 in the numerator. In the denominator, we still have this 2, and we have this one. And I'm not going to multiply them together. I'm just going to show that they're being multiplied. 2 times 3x plus 1. And that is our solution. Now it's your turn. Okay, here's the problem I want you to do. You're going to change it to multiplication by keep, change, flip, factor everything, and then cancel it all out. Go ahead and pause the video and give it a shot. So this is what you should be having for just the keep, change, flip part. Make sure you have that. Now go ahead and factor it. Is this what you got for when you factored it? It is? Fantastic. Go ahead and cancel stuff out. So a lot less canceled out this time. But you just multiply it across, and you don't have to do the distributive property on these at this time. We're going to just leave them in factored form, make it as simple as you can. We can always do that later if we need to, but at least we have the answer there. So if you got this as your answer, and I know you did, great job. Wonderful. All right, we'll see you in class.